let's start by talking about the sine function, right? You remember, so at the bottom of this page here that's on the screen, you see an example of what a sine function looks like, right? And you know that they're just basically waves that oscillate around an axis of reflection, right? And we also know that the full-fledged graph of the sine has a domain of negative to positive infinity and a range of negative to positive 1. So the default sine graph goes maximum 1 and minimum to negative 1, okay? And it oscillates in between. Another thing I want you to know here is, let's zoom in here and let's talk about the period. So when I start at x equals 0, the y value is 0, right? And we know sine of 0 is 0, right? And then sine goes and oscillates to 1, to 0, negative 1, 0, and over here, one cycle is completed, right? And by the time we complete one cycle, we have gone through 2 pi on the x-axis, right? It's just like on the unit circle, right? We start at, we start at 0. And what's sine of 0? 0. And then at pi over 2, what's sine? Sine of that is 1. And then here at pi, what's sine of pi? 0. And then what's sine at 3 pi over 2? Negative 1. And then I go back to 2 pi and sine is 0 again. Okay? So if these are the sine or the y values, 0, 1, 0, negative 1, 0. 0, 1, 0, negative 1, 0. And while I do that, I cycle through 2 pi. So we say the period is 2 pi, which means it takes a length of 2 pi for the sine to cycle through once, okay? So that's the sine function. The cosine function also has a domain of negative to positive infinity and a range of negative 1 to 1. And for the sine function, so let's see, when x is 0, for the cosine, at 0 degrees or 0 radian, what's the cosine? 1. So we start at 1, go to 0, negative 1, 0, and 1 again. And this is one cycle of cosine. And again, it takes a length of 2 pi for us to cycle once for the cosine. Okay? Yeah.
So for the sine, for me, it looks like it's like going at like 0, then like 1, but then, then back to 0, but then like negative, but then like it comes back up to 0 at the end. So wouldn't it be like 5 instead of that? Like it has like 5 different points.
Yeah, we're going to go through that, but right now we're just saying that it takes an interval of 2 pi for it to go through one cycle, okay? We'll get to points in a minute. Okay, so with the period is 2 pi, and because they repeat every 2 pi or every regular interval, these are called periodic functions, right? Just like the periodic table of elements, because every 8 elements, the properties repeat, right? And then just like a periodical is a newsletter or that you get every regular intervals, right? So that's what that means. Okay, now let's notice one other thing. Take a look at this green graph of the sine that I've highlighted. If I were to grab onto that sine graph, and if that was movable, and if I were to move it to the left a little bit, right, so that the peak went to the y-axis, wouldn't that look exactly like the cosine, right? So that's another big idea, that the graph of the cosine is just a horizontal translation of the sine, okay? Or you can move the cosine over a little bit and it'll be like the sine, okay? So they're related that way. And any graph like this, any transformation of a sine function is called a sinusoid. That's a good word to know, right? Sinusoidal functions are functions that are based on the sine function.
Sorry, can you say that again?
Sinusoidal functions are functions that are based on, I know it's funny to say, it's fun to say, sinusoidal function. Okay. All right. So general form, you learned this last year, is this, right? A sine bx plus c plus d. And same with the cosine. And so take a look. Each one of these, the A, B, C, and D, they each have a function or a purpose, right? And each are responsible for something. So let's start with A. A provides a vertical dilation. And in the case of these sinusoidal graphs, we call that the amplitude, right, of the sine or cosine function. So the amplitude is the absolute value of A. And the amplitude, if you take the sine or cosine graph, and if you draw a horizontal line through the middle of it, the amplitude is the distance from that center line up to a peak or down to a valley. Okay, so far anything new? Okay, so let's graph some. Here's how I want you to graph. Okay, so it says here to sketch 2 periods, but I'm going to change my mind and we're just going to sketch 1 period. So here's what I want you to do. Draw the x-axis. This is going to be the axis of oscillation for this one. So basically, first I'm going to graph sine of x, right? Okay, we said the period was 2 pi. So I start at 0, and then I go 1, 2, 3, 4. So yes, 5 total. You know what? I'm going to skip lines. I'm just going to make it wider a little bit. So I'm going to go 1, 2, 3, 4, okay? So you have your beginning point, 1, 2, 3, 4, 5 tick marks total. This is 2 pi. The midpoint is pi. Another midpoint is pi over 2, and this one is 3 pi over 2, okay? So the full period is 0 to 2 pi. Midpoint of that is pi. Midpoint of this is pi over 2, and then of that is 3 pi over 2. So if I want to graph this one, f of x equals sine x, I always start on the 0, go up to 1, 0, down to -1, 0, and that's what it looks like. Okay, the y-axis. I usually tell my students to, draw this and then put the y-axis here. You can do it before, but, do it after, like, you calibrate, So this is a 1. And we're going to label this f of x. Now, g of x is 3 sine x. What's the amplitude? 3. Let's draw g of x. I still start at 0. Any sine graph will start on the axis of oscillation. But now when I go to the maximum, now I have a maximum of 3. 0, minimum of 3, 0. Here, okay? And I label this g of x. Okay, so when we change the value of A, the amplitude, do you notice how the location of the zeros does not change? The location of the minimum and the maximum doesn't change either, right? The x values don't change, but the y values just become more extreme, okay? All right, so, okay, so next one, I have cosine x and -2 cosine x. So again, this next one too, we'll graph both, and then we're just going to graph the one. So cosine x as well, the,
Oh, wait, sorry.
I'll go back later. Okay, so cosine x as well, it goes from 0 to 2 pi. That's the default period. So 0, 1, 2, 3, 4, 2 pi. Okay, and then put these. These are the 5 critical points. And you need to have 5 points for any graph. So cosine, this is 1. Cosine starts on the maximum, then goes to 0, minimum, 0, maximum. Okay, and then when you draw this, it's not a V, this is not a absolute value function. So you got to give it that shape. Okay, here. Cool. Okay, so let's label this. This is f of x. Okay. G of x is negative 2 cosine x. What's the amplitude? 2, not negative 2. So, so for cosine, we never start on the axis of oscillation. We always start away from the axis. So here the amplitude is 2. We got to go 2 away. But do we go up or down? Down 2, then to 0, up to 0, down. Cool? G of x.
Wait, can you go to the very...
Later, Gabe, because we got to move on, okay? All right. So, periods. Okay. Whatever B is here, okay, 2 pi over that number B is the period of the sine or cosine function, right? So, you know that, some waves are like slow waves, and some waves are are much faster, okay? And, some are slow, right? So, do you see how, so if we take the distance between 2 corresponding spots, that's the wavelength. And if I take the distance here between 2 corresponding spots, like that's the wavelength, right? So you see how that's the period, I'm sorry. So you see how the period changes from one to another. Okay, so to find that, it's 2 pi over B. So, and then to graph it, what we do is we take that term bx plus c and we make an inequality from 0 to 2 pi. Okay, I think this is new from last year. Okay, good. So let's do this one. Okay, so here I'm just going to graph g of x. So for g of x, what's the amplitude? 1. Okay. For the period, the 1/2 is b, so I got to do 2 pi over b, which is 2 pi over 1/2, which is 4 pi. Okay? So that's the period, it's 4 pi. That means the length over which we're going to complete a cycle is 4 pi. Now, to graph this, here's what we're going to do. You go from, the default period is from 0 to 2 pi, correct? So you make an inequality that goes from 0 to 2 pi. And then in the middle, you put this, the stuff after the cosine, so 1/2 x. Multiply everything by 2. I get 0, x, 4 pi. Now, these will be the beginning and the end of the cycle. So, 0, 1, 2, 3, 4 pi. Okay? Okay, what's the midpoint? 2 pi. What's the midpoint between 0 and 2 pi? Pi. And between 2 pi and 4 pi is 3 pi. Okay, what are we graphing? We're graphing a cosine, so let's put the y-axis here. I start from 1, and then I go to the 0, -1, 0, +1, and there. Okay, so look. We said the period was 4 pi, correct? And what's the distance from 0 to 4 pi? 4 pi. So those two should be the same. Okay. Because the amplitude is 1. Okay. Frequency. Frequency is the reciprocal of period. Okay? So here, if the period was 4 pi, what would the frequency be? 1 over 4 pi. So its frequency is 1 over the period, which is b over 2 pi. So basically, period is how long it takes to complete one cycle. Frequency is if you were standing and like there was a wave passing underneath you, and if you were to time it, how many cycles can pass by in like a second? That's frequency. Okay? So if the period is short, the frequency is going to be higher because you're going to have like 4 or 5 waves pass. But if the period is long, only half a wave could pass, so it's at a lower frequency. Okay? All right. So take a look. A bass tuba can hit a note with a frequency of 50 cycles per second. That's hertz. And it's got an amplitude of 0.75. Write an equation for a cosine function that can be used to model the behavior of the sound wave associated with that note. Okay, what's the equation for a cosine function? Y is A, B, oh, sorry, A, B, C. All right, A cosine bx plus c plus d. Okay, so what are we given here? We're given that amplitude is 0.75. Okay. Is that A? Okay, go. Yeah. And then here we're given frequency is 50. So if frequency is 50, what is frequency? It's 2 pi over b, right? That's equal to 50. So what I need to find now is what b is. Yeah. I'm sorry. I got distracted. It's b over 2 pi. Yeah. Right, but then you had to do 2 pi over b. You still have to find the b. So b is 100 pi. Now, I'm not given any other information about the c or the d, so I can ignore those. We don't need them. So y is 0.75 cosine 100 pi x. Okay. Yeah.
Is this the same thing as the last example?
Yeah, so basically you're just given information to construct a function. Okay, let's graph some more. Let's talk about phase shift. Phase shift is if the graph has moved to the left or right. So you know how until now it was so boring because everything was starting at 0? Now, okay, things are not going to start with 0 anymore. Okay, things are going to get exciting now. Okay, let's do it. So, okay, phase shift, okay, it's negative c over b, but look, I hate highlighting that because then it becomes too many things for students to remember. I just need you to remember period is 2 pi over b. The rest, the phase shift, I want to show you how to find it. To find phase shift, you take bx plus c, set it equal to 0, solve for x. Okay? So, let's do this. Okay. Ooh, look at that function. How exciting is that? Okay. All right. Yeah.
Both frequency and period or b, right?
They, yes, use the b for both. Okay. What's the amplitude of this function? 2. Yay. What's the frequency? Oh, wait. Sorry. A period first. Period 2 pi over 5. And what's the frequency? It's the reciprocal of the period. 5 over 2 pi. Now, beware. Okay? Look, the pi is on the bottom here. Somehow students never believe that the pi could ever be in the denominator. And they always write the frequency as like 5 over 2 pi. No, no, no. It's wrong. And then other students really don't believe that it can be in the denominator, and they're not sure, and they kind of do like this ambiguous sort of, you know, like pi off to the side here, and you don't know if it belongs in the top or the... No, no. Be bold. And just boldly say it's 5 over 2 pi. It's okay, right? 5 over 2 pi. Okay? Okay. Phase shift. Here's what we're going to do. You take the, here, I'll work here. You take the stuff inside the parentheses, set it equal to 0, and solve for x. So 5x is negative pi over 4. Divide by 5, which is the same as multiplying by 1 over 5. So x is negative pi over 20. So x is negative pi over 20. What this means is that the graph has now shifted to the negative by pi over 20 units. Uh-huh. Yeah. Yeah. Yeah, I know, it is small. Like 1/20th of a pi. Okay, let's do this, guys. Okay, so here's what we're going to do. We are. That's what we're going to do now. Okay, so this is the default period of the sine function. So now, you take this and you put it inside there. I mean, it's so exciting though, right? And every year when I do this, it's been a year since I did it last, and it's like that cousin that you only see once a year, and when you do, you're just like, oh my God, I've missed you. So that's the sort of thing that we're doing here. Okay, so let's solve this, okay? Negative pi over 4. Negative pi over 4, negative pi over 4. This is why we make you take algebra 1 and algebra 2 before this, right? So you can, you know, manipulate these fractions. So, negative pi over 4, 5x, what's 2 pi minus pi over 4? 7 pi over 4. Now, divide by 5. Which means multiply by 1/5, multiply by 1/5. So I get negative pi over 20, x, and 7 pi over 20. Oops, pi over 20. Okay?
Couldn't you just put it in the parentheses in the first place? Not in the parentheses, in this like equation, without finding the phase shift.
Right, but sometimes that's all I want you to find, and so you need to be able to, you know, just do whatever. Hang on, let me finish this problem and I'll take questions. Okay, so take a look. Okay, the beginning of the period is negative pi over 20. Then I go 1, 2, 3, 4, 7 pi over 20. So do you see how until now we started at 0, and now we're starting at negative pi over 20? And remember how we said it had shifted over pi over 20 to the left side? Do you see that? Yes. Okay, now take a look here. We're going to do some math here. The very, very middle point, right? Midpoint. How do you find midpoint? Add 2 points and divide by 2. So that's going to be the half of negative pi over 20 plus 7 pi over 20. That's half of 6 pi over 20, 3 pi over 20. Right?
Yeah. Wait, are you multiplying the half and the 6 pi over 20?
Yeah.
Oh,
you see it? Okay. So look, now I'm going to do this blue one. Look up here for a minute. Let me show you how I talk it out. Okay? That blue one, look up here for a minute. It's halfway, okay, half of negative pi over 20 and 3 pi over 20, right? That's halfway between negative pi over 20 and 3 pi over 20. So that's half of, what is that? 2 pi over 20, which is just pi over 20. Always do this first, then we'll figure out where the y-axis goes. This last one, look, is halfway between 3 pi over 20 and 7 pi over 20. Believe it or not, this part here that I'm doing is the hardest part of the graphing, right? And it's just like, you know, mundane algebra. So half of 4 pi over 20, nope, 10 pi over 20. How much is that? 5 pi over 20, which is pi over 4. Okay, where does the y-axis go?
In between negative pi over 20 and 5.
Okay, so in between this and this. Okay, so, okay. I'm gonna, when I ask the class a question, we're gonna wait. I want you guys to raise your hands because I want to give everybody an opportunity to answer. Yeah? Do you have an answer or a question? Because I'm not taking questions just yet. So when you have this situation where you have negative a number and the positive of that same number, the y-axis is going to be smack in the middle of those. Okay? So here. That's the y-axis. And again, you know what? I'm going to take that back. I'm going to draw that later. Okay? I'm going to draw that later. Here's why. Okay, let's graph this. What were we graphing? We even forgot what we were graphing. Sine with a period of 2. Okay, the sine function starts on the axis of oscillation. Then it goes up to 0, down to 0. Graph that cute little function. Now I put in the y-axis. And the reason why I do that at the very end, I know it's counterintuitive and it goes against everything we taught you in your life about graphing, but it actually, like, sometimes it confuses you to put where those, like, to know where to put those critical points. So there we go. There we go. Give yourselves a hand. Look at the complicated function we just graphed. Okay, okay, Gabe, what was your question? Quick, I really need to hit this place home. This starts from here and it ends here. So it starts at negative pi over 20 and it goes to 7 pi over 20. Let's find the distance between those points. So 7 pi over 20 minus negative pi over 20, right? That's 8 pi over 20, which is 2 pi over 5, which is exactly what we got for the period, right? So we said there had to be an interval of 2 pi over 5, okay? And for the cycle to complete, so that's another way that, you need to make sure that those things like match up. Okay, let's do one more. Here, the difference here is that, we have this, we have this function. and it's got a +1, which means it's got a vertical shift of 1. So how much is the amplitude?
1/2.
Hey guys, raise your hands, please. Huh? Amplitude is a half.
But what about the +1 then? You just said that it adds.
No, that is the vertical shift. So I'll show you what that does right now. The period is 2 pi over b, which is 2 pi over 1. Frequency is 1 over 2 pi. Okay, phase shift. X plus pi equals 0. X is negative pi. Okay, now take a look. This is the x-axis. Okay, now I take the x plus pi and I put it between 0 and 2 pi. So now it's negative pi, x, pi. So here I have negative, okay, you know what, this time I'm not gonna skip I'm just gonna go one box at a time, just to show you guys that I can. Okay, so this is pi. 0 is in the middle. Negative pi over 2, pi over 2. Now look. This 1 means the whole thing is shifted up 1 unit, so it's here. Okay? So now that's the new axis of oscillation. Now, how do we graph this? This is a sine, so I start on the axis of oscillation. I go up a half, 0, down a half, 0, and look, it's like such a cute little function. Okay? And the y-axis goes on the 0 here. Okay. Yeah.
Why do you make it so compressed?
I just said I'm gonna do it that way just to show you I can, because some people have a preference, you know. Okay. Okay, here, write an equation that corresponds to this. We'll do this one too, and then we can just leave the other one for tomorrow.
Could you just go back upstairs?
Okay, so what do we need here? We need A, B, C, D. Okay, so first, figure out if this is sine or cosine. To do that, I like to, well, to do any of it, you have to split it down the middle like this vertically. And so now, do you see how at the very beginning, right here, it starts on the axis of oscillation and not away from the axis? That tells you it's going to be a sine graph, okay? Because it starts on the axis of oscillation, the red one, it's a sine graph. Now, what's the amplitude? 1, 2, 3, 4. Amplitude is 4. It's hard to count because it's so little. Okay, period. Boom. That's 1 period. It takes an interval of 4 pi to complete. So, period 2 pi over b is 4 pi. So 2 pi is 4 pi times b. B is a half. Okay. There is no phase shift because it starts right at y equals 0. And d, how much is d? The whole axis of oscillation is down 2, so -2. So now, what's the function? Y equals a sine bx plus c plus d, right? And we just said there is no c. So this is y equals 4 sine half x in parentheses minus 2. Okay?
What does the D mean?
The D is the vertical shift. So this is the x-axis, but the axis that it's oscillating around is further down. So there we go. Okay.
Wait, So why is there? Oh, there's no C, but there is the VX. Wait, what is the C again? Did we talk about that?
No, you know, for these, I'll probably not give you a phase shift. That's the phase shift.
Oh, that is.
It gives you the phase shift. Okay, so hang on. For homework, you can pretty much do all of the homework. So I've condensed it into one day. I knew we weren't going to take 2 days, but I just put it just in case. So I'm going to give you guys a modified schedule tomorrow. For homework, you can do everything, except there is one problem that looks like this that you can skip, but the rest you can really do all of it, okay? So that next homework is due tomorrow, and you can go. Thank you very much.
Is it a modified